Okay, we're going to pick up with Unit 6, Lesson 2, which is approximating areas with Riemann sums. These are rectangular approximation methods, and we talked yesterday about being able to find the area under a curve, like we have here, by dividing the region, or the interval 0 to 3, into 12 rectangles. And the rectangles can be drawn a number of ways. We can use the left ram, this is L ram, using the left endpoint of each rectangle. We can use the midpoint, or the M ram, which, if you notice, the the rectangle is intersecting the graph in the middle of the rectangle. And then we have the right ram, or right rectangular approximation method, and you'll notice that the rectangles are intersecting at the rightmost point on the rectangle. So we started the process yesterday of determining how to find the area, and I'm going to pull this sheet off. We know that we find the area using length times width, or base times height, either one. And so what we did, I'm going to redraw this graph. Here is the graph. That's pretty sad. There's 3. We divided this into 12 rectangles. And what we decided is that we needed to determine the width of each rectangle. So we started out with the problem saying let's use 12 rectangles. We have the velocity function, which represents this function as v of t equals t squared. To find the width of the smaller rectangles, we take the interval 0 to 3. So 3 minus 0, divide that by 12, the number of rectangles, and then that reduces to 1/4. So looking at the first rectangle, I'm going to make this, I'm going to make this really big. So if this is the first rectangle, and this is the second rectangle, then this marking is 1/4. This would be 2/4, the next one would be 3/4, and we would carry that all the way down to 3, which would ultimately be 12/4. So what we need to do is we need to find the base, or the width of each rectangle, which is going to be the same, 1/4, but we also need to find the height of each rectangle. So for rectangle number 1, the interval is going from, the first rectangle goes from 0 to 1/4. And let's talk about how to find the height of, this rectangle, using the midpoint. We'll get our height from whatever the midpoint is. We'll take that value and we'll evaluate it into our function to get the height, because the height of each rectangle is intersecting the graph of the curve. So to find the midpoints, I'm going to find the midpoint of the first rectangle, and that is, that's easy to see where it would be 1/8, but just in case we don't have a nice little function or nice little numbers that we can figure out what the halfway point between 0 and 1/4 is, we need to have a way to determine that. So we'll take 0, we'll add 1/4, we'll get 1/4. Now simply multiply that by half, and we get 1/8. So we have our midpoint. Now we can find the height. So we find the height of the rectangle by taking our midpoint and substituting it into the velocity function. So v of 1/8 will be equal to 1/8 squared. So we're just plugging the 1/8 in here, and that will give us 1/64. So we talked yesterday, or not necessarily yesterday, but anyway, we talked about how this seems like we're going to have to do this 12 times because we have 12 rectangles. But what we'll do is we'll end up seeing some sort of pattern, and we'll be able to minimize the amount of work that you think we're going to have to do. But that's the information for rectangle number 1. Okay, so now let's take the rectangle number 2. That rectangle is going to go from the interval 1/4 to 2/4. I'm just going to leave it as 2/4 because it will make finding the midpoint easier. So to find the midpoint, we'll take 1/4, add 2/4, which gives us 3/4, multiply that by half because we're finding the midpoint. So that's going to give us 3/8. And then to find the height of that rectangle using the midpoint, I will evaluate the velocity at 3/8. V of 3/8 will equal 3/8 squared, which is going to be 9/64. Okay, so we have 1/64 as the first height, or the height of the first rectangle. We have 9/64, which is going to be the height of the second rectangle. So now I'm going to go to rectangle number 3, and that interval goes from 2/4 to 3/4. Oops, that's not necessary. I need to find the midpoint. So I will take 2/4, I will add 3/4, which gives us 5/4. Multiply that by half, and we get 5/8. To find the height of that third rectangle, I will take my 5/8 and evaluate the velocity function at 5/8. So I'm now going to have 5/8 squared, which is going to give us 25/64. So here's the height of the third rectangle. So if you think about it, I hope you've already noticed that all of the denominators of the heights are going to be 64. And if you really pay attention to the numerators, this is 1/64, 9/64, 25/64. So the square root of the pattern is 1 squared, 3 squared, 5 squared. The height of rectangle number 4, without even finding the midpoint, the height is going to be 7 squared, or 7/8 squared, which is going to give us 49/64. So here are the heights of the first 4 rectangles. So knowing that we've just picked up on this pattern, I think we can determine the heights of the remaining 8 by just using the pattern. So I've run out of room, so I'm going to get some more paper, and this time I'm going to use notebook paper, sorry. But here's what we have, okay? So rectangle number 1, the height was 1/64. Number 2 was 9/64. Number 3 was 25/64. Number 4 will be 49/64. The fifth rectangle will be That was 7. How about 9 squared? That would be 81 over 64. The 6th rectangle, that's going to be 11 over, or 11 squared over 64, so that's 121 over 64. I'm going to come back up here. Number 7, that was 11, so 13 squared is going to be 169 over 64. Number 8, the 8th rectangle, that was 13. Now it's 15 squared, which is 225 over 64. Ooh, we're finally going to get there soon. The 9th rectangle will be, that was, what was that, 15? 17 squared, which would be 289 over 64. Number 10, rectangle number 10, what did I say that was, 17? 19 would be 361 over 64. Rectangle number 11, that was 19. 21 squared is 441 over 64. And then finally, rectangle number 12 gives us, that was 21. 23 squared is 529 over 64. So, you know, if we were still doing all of the calculations like we did here, you know, we'd probably be around rectangle number 8 maybe. But being able to pick up on the pattern eliminated us having to do all the work. Now, how did we come up with how did we determine all of these heights? Well, just remember, we took the velocity function, v of t equals t squared, and we evaluated this at all of the midpoints. So the good thing is we didn't have to go through and find all the midpoints once we determined the pattern. Okay, so now that we've got all that nasty work out of the way, how do we find the area under this curve? Okay, so visually, this is what we're doing. Okay, we're now going to be able to find the area under this curve. If we can find the area of each of the 12 rectangles, we can add those up and we'll have our total area. So remembering that the formula A equals length times width, we can find the area. So let's start out with the first rectangle. So what was the width of the first rectangle? It was 1/4. Multiply that by the height. And what did we find the height to be for the first rectangle? We found that to be 1 over 64. So it's 1/4 times 1 over 64. Then I will add the area of the second rectangle, and the width of the second rectangle is 1/4, and the height of the second rectangle will be 9 over 64. And then plus, and I'm going to continue doing this for all 12 rectangles. But if you think about what's happening here, what do all of the areas have in common for each of the rectangles? Well, they each have a uniform width of 1/4. So really, what if we were to do this? It'll condense, it'll make it a little simpler. We know that 1/4 is going to be common to all of the areas. What if I just do 1/4 times the sum of all the heights? So that would be 1 over 64 plus 9 over 64 plus 25 over 64 plus 49 over 64. And I'm going to do a dot, dot, dot. And I'm going to do that all the way until I get to the last one. So plus 441 over 64 plus 529 over 64. Okay, so this is just a little bit more abbreviated a more abbreviated way of writing the area of the entire, of all 12 rectangles. Okay, so jumping to the answer, we're going to have 1 over 64. I will simply tell you that all of these 12 values add up to be 2,300 over 64. And if we condense that a little bit more, we're going to get 2,300 over 256, and that will calculate out to 8.984. So, what does that value mean? What does that value represent? Well, remember, this is the velocity curve, this is v of t, and the x-axis is time. And so this value here tells us that the particle is 8.984. I don't think there were any units. I think we decided on feet. But anyway, the particle is 8.984 feet from its starting point at t equals 3. Or you could say at t equals 3, the particle is 8.984 feet from its starting point. And I didn't write the word point. So the idea behind finding the area is to use, under a curve, is to use a rectangular approximation method. And what we did is we used the midpoint. And to put that in perspective again, and you know my drawings are terrible, but this is, remember, this is when the rectangle drawn, here's the rectangle, it intersects the graph at, the graph of the function at the midpoint of the top of the rectangle. So that is finding the area using an MRAM, a midpoint rectangular approximation. I'm going to stop this video and then I'm going to create another using the left approximation method and the right RAM, left RAM and right RAM.